This one was a little interesting, and if I remember correctly. Did I do that on this side? I don't do that. Oh yeah, okay. So I'm going to change the tangents into sine over cosine, and the cotangents into cosine over sine. Okay, and this should be an exponent of 2 in case that's not clearly written. All right, so similar in the first choice of step, in that getting rid of these denominators, sine and cosine, would be a good idea. So I'm going to multiply top and bottom by sine and cosine. All right, well, when we multiply the first sine squared, we're going to get sine cubed cosine. And then when we multiply the next one, the cosines are going to divide off, and we're going to get sine times sine, which is sine squared. And then on the bottom, similar, when we multiply to the cosine squared, we're going to get cosine cubed, and then sine. And then when we multiply the fraction, the signs are going to cancel, and we're going to get cosine times cosine, which is cosine squared. So that first step appeared to be unavoidable. And then maybe we're not sure where we're going with this, but certainly getting the denominator sine and cosine eliminated is a good idea, and we can multiply top and bottom of a fraction anytime we want. And then looking at this, well, it looks like we can factor out. In the numerator, we got a sine cubed in one term and a sine squared in the other term. In the denominator, we got a cosine cubed in the first term and a cosine squared in the second term. So we're going to factor out the smaller exponent, which would be sine squared and cosine squared. And look at that. Those are the same. The order of multiplication doesn't matter, because you can make this sine times cosine. So then what's left is this, which is the tangent squared.